Am I audible and is the PPT visible? So hope you're all doing good and preparing very well for the exams. So let me introduce myself first. My name is Nashwa and I'll be handling ICT sessions for you. So today is our first session, and in this session, we'll be discussing the introductory aspects of ICT and also some basics related to computer parts and components. Okay, so let's begin our session without any delay. So you must have already gone through ICT syllabus, and when comparing to the other units, we have a very much shorter syllabus. But as you can see that although the syllabus is very short and very much specific, it is having many different subtopics in it. Like we can say it is a much generalized kind of syllabus. So we'll just go through the syllabus of ICT. First, we have ICT's general abbreviations and terminologies. And then we have basics of the internet, intranet, extranet, and video conferencing. And then comes digital initiatives in higher education and ICT and governance. So as I said, it is a very general syllabus. And under this, we have many different subtopics to discuss. Okay, so we'll be discussing the introductory aspect of ICT today as a beginning. Okay, yes. So to begin with, we'll be looking at what do we mean by, or what does it mean by information and communication technology. ICT is nothing but the abbreviation of information and communication technology. It is a very broad field. We can say it is a very broad field. And this ICT can be divided into two parts. That is IT and CT. So information and communication technology is a combination of IT and CT. IT simply means information technology, and this word might be much more familiar to you people. So information technology means nothing but the collecting of data or information and the processing and the storage of data with the use of technologies. Okay, it is nothing but with the help of technology, we collect, we process, and we store the data or information. So that is included in the IT part of ICT. And next we have CT, communication technology. And in this part, the collected or the stored data is transmitted or transferred to other networks with the use of communication technologies. Okay, it simply means that the information that is collected, processed, and stored in the case of IT, it is now broadcasted or transmitted to other networks by the use of communication technologies. And when we say communication technology, it can be wireless or wire technologies. So information and communication technology is nothing but the combination of IT and CT. Hope it is clear. And it is a very comprehensive field. As we said before, it is a combination of both information technology and communication technology. And so there are many different technological tools that are associated with ICT. And thus we can say it is a very much comprehensive field that includes hardwares, softwares, networks, and the use of telecommunication devices to enhance communication. So let us just take a look at the definition which is given in the PPT. Information and communication technology refers to a broad range of technologies which is utilized to manage, transmit, and exchange information. So the basic aim of ICT is nothing but to exchange information or to transmit information. Okay, so here information and communication technology is nothing but the broad range of technologies. Many different technologies are involved in ICT, and these are utilized for what? To manage, to transmit, and exchange information. Okay. Yes. Now, ICT encompasses the convergence of various technological tools and systems that facilitate the acquisition, storage, processing, and dissemination of data. So as we said before, the basic aim of ICT is to share information or to disseminate data. And it is a comprehensive field which includes hardwares, softwares, networks, and the use of telecommunicational devices to enhance communication and access to information. So in order to give access to information to a wide range of people or to a global network, a vast number of telecommunication devices are used or employed in terms of ICT. Okay, so that's all about the introductory aspect. Now let's take a look at our first topic. We'll be discussing computer generation and types. So talking about computer generations, it is a very simple topic. And when we take a look at our previous year questions, we can see that at least one question is asked from this topics. So if you are familiar with this area, we can easily score that one question. Okay. So in computer generations, talking about computer generations, we can say that we know that the computer that we see today, it has gone through many different stages or many different generations to look like what we see today. So we have 5 different generations of computers. And in the first generation, please note down the dates of the generation. Okay, it is very important. First generation date comes between 1940 to 1956. 1940 to 1956. Usually years are asked in for the exam. Okay, so in the case of years, you might be having some confusion regarding the year because maybe in some materials or in Google, you might find different years, like almost similar years. So you need not get tensed regarding the year. Please note down the era, like 1940s to 1950s was the first generation. 1950s to 1960s was for the second generation. So please keep that in mind. And so things will be much more clear. Okay, so now let's take a look at the first generation. This generation marked the advent of electronic computers. It was the beginning of electronic computers, and here in this generation, vacuum tubes were used. Okay, so here you can see the picture of vacuum tubes. You can see that it is a very big kind of material. So for the first generation, these vacuum tubes were used to make up computers. And this vacuum tube itself is very large. And so the computer was very much big. We can say that it almost took one whole room to occupy this first generation computer. So it was that big. Okay. So here you will have to note that vacuum tubes were used in the making of the first generation computers. And thus it was very large in size. It was physically very large in size. And also there are some limitations. You can see in the PPT it is given. It is larger in size and there was high energy consumption, low operative speed, and it got heated very shortly. Okay, so please note down the limitations. And also the examples for first generation are ENIAC we can say. And you can also note down the expansion of ENIAC. It means electronic numerical integrator and computer. It is very important. It is often asked in the exam. So the full form is electronic numerical integrator and computer. And other examples are UNIVAC, EDVAC, IBM 701, and IBM 650. Please note down the examples. Now, are you familiar with the term IBM or what is IBM? Can anybody tell me? Okay, what is IBM? Have you heard about IBM? Nobody. Okay. So IBM is nothing but it is a computer manufacturing company, and the first generation computers were made by IBM also. IBM was also involved in that, and it was a very famous company until Intel came into market. You might be much more familiar with Intel because nowadays in computers we use I processors, right? i3, i5, i7 processors are used in computers, and that is brought about by Intel. So IBM is also a very famous, it was a very famous computer manufacturing company, and it had its major role in the first generation computers. Okay, so in first generation, you will have to note that vacuum tubes were used up in the making of the first generation computers. And it was very much larger in size, and the energy consumption was very high. It had low operative speed, and it got heated very shortly. And please note the example also: ENIAC, UNIVAC, IBM 701, IBM 650, etc. Okay. So the second generation computers came up between 1956 to 1963. As I said before, please note 1950s to 1960s. Keep that in mind. Otherwise, you might get confused with the proper year. Okay, so to be precise, you can note 1956 to 1963 as a year of second generation of computers. And here, instead of vacuum tubes, transistors were used. You can see in the picture, a transistor is given. And comparing to the size of the vacuum tube, the size of the transistor is very small. When compared to the vacuum tube, it is, we can say it is like this much maybe. So the transistor size is very small, and thus the computer size was also very small when compared to the first generation of computers. And in the second generation, assembly language programming was used. Okay, please note, assembly language programming was used in the second generation. And the second generation computers relied upon punched cards for input and printouts for output. That is very important because the computer that we see now, it has a monitor or a keyboard, like that format is there. But in the first generation and second generation, there were no monitors or keyboards as such. Instead, there were punch card for input and printouts as outputs. Okay, so here in the second generation computers, what we do is that there'll be a small card, which is called as punch card, and we'll be giving the data, which is given to be as input into the computer. And the computer will process those data in the punch cards and give us output through printouts. So that was the way how second generation computers worked. So please note that. And some of the examples of second generation are given. IBM 1401, IBM 1901, IBM 1400 series, etc. So in second generation also, IBM had brought about many different computer models. Okay. So now let's take a look at the advantages of second generation computers. We said that when comparing to the first generation, since transistors are used in the second generation, the size of the computer had considerably decreased. So they were smaller in size when compared to the first generation, and they had become much more faster and more reliable than the first generation of computers since transistors were used in them. Okay, and they were much more easier to maintain than the first generation computers. Now let's take a look at the disadvantages. They were still quite large and required air conditioning to prevent overheating. They were still quite large, as I said before. When comparing to the first generation, they were small in size. But although they were small when comparing to the first generation, they were much bigger in size. That is, in the first generation, we said that the computers almost required one whole room to occupy. In this case, it turned out to be a little bit smaller. That's it. Okay. And also, there required air conditioning to prevent overheating because the computers were heated very shortly and air conditioning was required to prevent it from getting overheated. And one thing is that the programming of the computer was very much complex and it could run only one program at a time. This is very important in the case of second generation. This generation of computers could run just one program at a time. We know that the computers that we use today, what do we do is that we open like one website in one tab and another in the next tab, etc. and so on. And we use multiple websites at a time. But here in this case, only one program could be run at one time. And that is one of the main disadvantages of second generation of computers. Okay. Hope it is clear. If you have any doubts, you can tell me in the chat box. Okay. Now, the third generation of computers came. Okay. Yes. Is there any problem? Okay, I'll be repeating once more after I finish all the 5 generations. Is that okay? Okay, okay, fine, fine. Yes. Okay, now. So talking about the third generation came about in 1963 to 1971. So please keep in mind 1960s to 1970s was the time of the third generation. And in this generation, instead of here transistors were used. Okay, please note that in instead of transistors, integrated circuits were used in the third generation. Very important. Integrated circuits were used in the third generation instead of transistors. And you can see the picture of an IC, which is given in the PPT. It is very much smaller than, when compared to transistors, it is much more smaller than transistor. And so the size of the computer decreased to a larger extent. We can say that it almost became in the form that we see today. Okay. Yes, so please note down the main characteristics of the computers also. It consisted of an integrated circuit. An operating system came into effect. Okay. An operating system was introduced in this generation. It is also very important. Now, what do you mean by OS? Can you give me some examples for OS? Anyone? Please give me some examples of OS. Have you heard about operating systems? Okay. Yes. Yes, Microsoft Windows is an example for OS. Any other example? We'll be discussing about operating systems in detail later. Okay. So Microsoft Windows is an example for operating system. Operating system is nothing but for a computer to function effectively, we require an operating system. In simple words, as I said, we'll be discussing about this later. So for a computer to function, we require an operating system. And one of the examples for operating system is Microsoft Windows. We can say Mac is another operating system, and our Android, etc. These are all operating systems. Okay, so in third generation, there came the introduction of operating systems, integrated circuits, and high-level programming languages. Please note, high-level programming languages came into effect. High-level programming languages examples are also given. COBOL, Fortran, etc. were introduced in this generation. And also this generation consisted of time-sharing systems. Time-sharing system is nothing but this generation computers could be accessed by multiple people. Okay. The first generation and the second generation could not be accessed by multiple people. There was like one man, one time system. But in the third generation, multiple persons could access this computers. So that is called as time sharing systems. Now, please take a look at the examples. It includes IBM 360, IBM 370, PDP 11, IBM System 360, Honeywell 6000, etc. Okay. Now, let's take a look at the advantages of third generation. The integrated circuits made computers even smaller. So it is notable that from the first generation, as we move from the first generation to the last generation, the size of the computers decreased. We can see that because in the first generation, very large vacuum tubes were used in the making, and thus the system was itself very large. It occupied very much space. And the second generation, transistors were used, the size was decreased. And the third generation, ICs are used, and the size is much more decreased. Okay, so integrated circuits made the computers even smaller, faster, and more powerful. Okay, and they introduced high-level programming languages like COBOL, Fortran, etc., making it easier for people to read and write the programs. User interaction started through keyboards, monitors instead of punch card. That is also notable. In the first generation and second generation, punched cards were used, but in this generation, keyboards and monitors, etc., came into effect, and it was much more like the computer that we see today. And the use of operating system allowed the device to run many different applications at one time. In the case of second generation, we had mentioned that the second generation computers could run only one program at a time, right? Only one program at a time. But in the case of third generation, different applications or different programs could be run at a single time. And thus, it was possible only because operating systems were introduced in this generation. Now, time-sharing systems allowed multiple users to access the computer simultaneously. So when comparing to the second generation, we can see that the computer had become much more reliable, right? The first thing is operating system was introduced. And since operating system is introduced, more than one application could be run at a time. And time-sharing system came into effect and multiple users could access this. And then high-level programming languages were used. And because of that, people could read and write the programs. Okay, so the computer as a whole became much more reliable. Now, let's discuss the disadvantages of the third generation. They were still expensive and not widely accessible to the general public. Okay, so the third generation computers were much more expensive, we can say, and also it was not much widely accessible to the public. Okay, only the access is limited to a number of people. It was not completely accessible to the public. And they required skilled operators to maintain and operate. That is one of the main disadvantages of this generation. That is the maintenance and the operation of this generation computers required skilled operators. Okay. Okay, I hope it is clear. If you have any doubts, you can ask in the chat box. Okay. So here comes the fourth generation. The fourth generation came up in the year 1972 to 2010, or you can just simply remember it as 1970s to 2010. Okay. The fourth generation of computers were developed by using microprocessors. Okay. Here came the use of microprocessors or CPU technology. It is very important. In the fourth generation, they used microprocessors, CPU technology, or we can also say it used VLSI technology. Does anyone know what VLSI means, or do you know the expansion of VLSI? Have you heard about VLSI? Anyone? What is VLSI? Okay. VLSI simply means very large scale I hope my handwriting is readable. Very large scale integration technology. Okay, so in the case of fourth generation, we can say microprocessors came into effect and it used CPU technology or VLSI technology. VLSI means very large scale integration technology. And now, why do we say it is VLSI or very large scale integration? It is because here microprocessors are used. And microprocessors are nothing but it is just the combination of thousands of ICs, integrated circuits. As we said before, in the third generation, integrated circuits was used. Many different, thousands of integrated circuits were combined to form the microprocessors. And since that kind of microprocessor is used in the fourth generation, we call it as very large scale integration technology. Yes, I hope it is clear. Okay, now let us take a look at the main characteristics of the fourth generation computers. It included the microprocessors and personal computers came into effect. Please note, PCs came into effect in the fourth generation because we said that in the third generation, although the computer had become much more reliable when comparing to the other two generations, but it was not generally accessible to the public, right? But here in the fourth generation, personal computers came into effect. Okay. And also graphical user interfaces came into effect. Now, what do you mean by graphical user interface? Have you heard about graphical user interface? Anybody? Graphical user interface is, in short, called as GUI. Okay, so graphical user interface is nothing but it is something through which a user interacts with electronic devices like computers through the use of icons or menus, scroll bars, pointers, etc. Okay, so graphical user interface is something that allows the user to interact with the computer. For example, how do we interact with the computer that we use today? We normally use either the mouse, the pointer to click on something. If you want something, like if you want to run a program, you click on you use a mouse to point out something. And then we use menus or scroll bars or icons as such. So these are all known as graphical user interface. It is nothing but something which allows the user to interact with the computer. So graphical user interface was also introduced in this fourth generation of computers. And please note, there was also the emergence of internet. Fourth generation marked the emergence of internet also. Okay, so what are the main characteristics of the fourth generation? It included microprocessors and personal computers came into effect. Graphical user interface was introduced. Networking came into effect and there was emergence of internet. Now, examples of fourth generation is IBM PC, IBM's personal computer, and Apple Macintosh. Apple Mac also came into effect in the fourth generation. Okay, so now let's discuss the advantages of the fourth generation. The fourth generation led to the creation of personal computers. That is one of the main advantage, making computing accessible to all. Okay. And the second advantages is graphical user interface, GUI, made computers much more easier to use. Okay, since graphical user interface was introduced, the users could completely interact with the computer and the usage of the computer became much more easier. Now, talking about the disadvantages, early PCs were relatively slow and had limited memory and storage. That was one of the main disadvantages of the fourth generation. The personal computers which was introduced during this era, they were relatively slow when compared to the present computers and had limited memory and storage capacity. Please note, limited memory and storage capacity, and they were relatively slow. They were also prone to viruses and security vulnerabilities. Okay, so there occurred security vulnerabilities also. Okay, so in the fourth generation, it is notable that microprocessors were used, CPU technology was used, or we can say VLSI technology was used. VLSI means nothing but very large scale integration technology. It is called as VLSI since the microprocessor is made up of thousands of integrated circuits. Thousands of integrated circuits make up one microprocessor, and that was used in this fourth generation computers. And so came the name very large scale integration technology. Okay. Now, the main characteristics are, as we discussed, microprocessors came into effect, personal computers came, graphical user interface was introduced, and also internet came into effect. Please note down the examples. And the disadvantages are that the PCs were relatively slow at that time, and they had limited memory and storage capacity, and also they were prone to viruses and security vulnerabilities. Okay. So now we have our last generation of computer, the fifth generation. The fifth generation came into effect starting from 2010 to the present generation. Okay, so in this generation, there came in artificial intelligence. So one of the drastic technology that came into effect was artificial technology in this generation. And there were some other technologies also like quantum computation, nanotechnologies, etc. I think it is not mentioned in the PPT. Please note down. Quantum computation technology was also used in the fifth generation. And another technology is nanotechnology. Okay. So in the fifth generation, some of the technologies used were artificial intelligence, quantum computation, and nanotechnologies. This generation included software also, which is very important. This generation included software also. Until now, software was not much used. Operating system was there, but not proper software was there. So in the fifth generation, a software was introduced, and some of the examples of fifth generation are Param 10,000, IBM notebooks, etc. Okay, so now let's take a look at the advantages of the fifth generation of computers. These computers were much far quicker than previous generation. Okay, yes, we can see that because here the technology used is like AI, nanotechnology, etc. And the computer had become much more faster when comparing to all other generation. Okay, and these computers are simpler to repair. They were very easier to maintain and smaller in size than other generation computers. They were lightweight and easy to move. True artificial intelligence is being developed. Parallel processing has progressed. Now, parallel processing is also another technology. You may also know that. Parallel processing had progressed. Superconductor technology has also progressed. Now, the disadvantages are that the complexity of AI systems can sometimes lead to unexpected bias. Privacy and security concerns have become more pronounced within this. Okay, so the two disadvantages are that since AI is used, the complexity was there, that complexity term was there, and also security problems also aroused. Okay, so that's all about the 5th generation of computers. We'll just go through all the generation one more time. Talking about the first generation of computers, this generation of computers came in the era 1940 to 1950s, specifically speaking 1940 to 1956. And here vacuum tubes were used. Vacuum tube itself is very large in size, and so the computer was also very much larger in size. It almost took one whole room to occupy the computer. Now, the main characteristics are vacuum tube usage, magnetic drums were used in this generation. There were limited programming capabilities and large physical size. Some of the examples are ENIAC. Please note down the expansion of ENIAC, Electronic Numerical Integrator and Computer. Another examples are UNIVAC, EDVAC, and IBM 650. The limitations are they were much larger in size, high energy consumption was there, low operative speed, and they got heated shortly. Now for the second generation came into effect in 1956 to 1963, broadly speaking, 1950s to 1960. And here vacuum tubes were replaced by transistors, and they were much more smaller, faster, and more reliable computers. Here, assembly language programming was used, very important. And also the first and second generation of computers relied on punched cards. There were no monitors or keyboards as such. Inputs were given through punch cards, and the output was got by printouts. And some of the examples are IBM 1401, IBM 1920, IBM 1400 series, etc. The advantages are they were much smaller in size, they were faster and more reliable only when compared to the first generation. Please note that. Okay. In disadvantages, we can say that they were still quite large, and also they required air conditioning to prevent overheating, which means they were heated up shortly. And also programming was very much complex. Only one program could be run at a time. Okay. Now for the third generation came into effect in 1963 to 1971. Here integrated circuits or ICs were used instead of transistors. Now, as you can see, ICs are very much smaller than transistors, and so the size of the computer was reduced to a large extent. Now, for the main characteristics, the operating system came into effect. The operating system came into effect in this generation. High-level programming languages such as COBOL, Fortran, etc. were used, and time-sharing systems came into effect, which means that multiple users could access the computer at a single time. And some of the examples are also given. And for the advantages, we can say that high-level programming languages made it easier for people to read and write the programs. Use of operating system made it accessible to access more than one program at a time. Time-sharing systems allowed multiple users to access the computer simultaneously. And for the disadvantages, they were still expensive and they were not much widely accessible to the general public, and they also required skilled operators to maintain and operate these computers. Okay. Now for the fourth generation, microprocessors were used in this fourth generation with the help of CPU technology and VLSI technologies. And the main characteristics involves the advent of the personal computers. Graphical user interface was came into effect in this generation. Graphical user interface is nothing but the interface that allows users to interact with the computer. And also internet came into effect in this generation. Okay, so here as disadvantages, we can say that the earlier PCs were relatively very slow and they had limited memory and storage capacity, and they were also prone to viruses and security vulnerabilities. Now for the fifth generation used wide varieties of technologies such as artificial intelligence, quantum computation, nanotechnologies, superconductor technologies, parallel processing, etc. You may note down all of these technologies for your references. Okay, now since technologies like AI was used in this generation, it was much more complex in nature. That is one of the disadvantages of this generation. And also it was much more vulnerable to security problems. Okay. So as a whole, we can say that as we move from the first generation to the last generation with the development of technology, there had been drastic changes. We can say that the computer as a whole had become much more faster and much more smaller in size, and the weight is also increased. And overall, we can say that when comparing the first generation to the fifth generation, the computer had become very much reliable to use and manage. Okay. So that's all about the generation of computers. Please take a look at the table. Here, generations are given in the first column. The second column, the main electronic computers are given, or the system which is, or the technology which is used in each generation is listed. And the third column, symbolizes the operations used in different generation of computers, and languages are also mentioned, and some of the examples are also given. Okay. So here is the pictorial representation of the 5 generation of computers. As you can see, the first generation computer occupies very much larger space. The second generation, comparing to the first generation, it had become smaller in size, but still it is quite large in size. And third generation, we said that the monitor and the keyboard, etc., came into effect, and it is almost similar to the computer what we use today. Okay. And then came the 4th generation of computers with the slight change. And here is the 5th generation computer. Okay, yes. Okay, somebody had asked me regarding the operating system and software being used in the 5th generation. In the 5th generation, software was introduced. We'll be discussing regarding the software in detail, like what are softwares, like what are the different types of softwares, etc. And then you'll be getting a clear-cut idea of softwares and operating systems. Okay. So now we'll be discussing regarding the basics of computers. Okay. Basics of computer means, what do you mean by computer? For what purpose computer is used? What are the different components of computers? You might be thinking that these are very much basic topics, but they are in fact necessary for from the exam point of view, because often questions from these areas are also asked. Okay. So now what is a computer? A computer is an electronic machine, right? We call a computer as an electronic machine because electricity is used to run computers. So it is an electronic machine that processes information and performs tasks based on programmed instructions. So what does the computer do? The computer processes information and it gives us output. So the computer as a whole, it does not have brain of its own, right? We need to give some instruction to the computer in order to process. So we will be giving some data as input to the computer. The computer will be processing the data and it will give us output as like in a way that how we require it. Okay, so now this computer consists of hardware components such as the central processing unit, CPUs, memory, storage, and input-output devices, etc. And it also includes softwares, which are the instructions and carry out functions like calculations, data processing, and communication. So talking about computer is an electronic device. We give input to the computer and the computer processes the data and it gives us the required output. So for this purpose, for this process to occur, the computer consists of hardware components as well as software components. Hardware components means nothing but the components which can be physically seen. For example, input and output devices, which includes monitors, CPUs, or the keyboard, monitors, mouse, etc. These are hardware components. Now, what about the software components? For a computer to function or run a program, it requires a software. Or softwares are nothing but the instructions or the programs that are stored in the computer for a program to run. Okay. So now we'll be discussing about input devices. Okay, now what are input devices? As we said before, computers have hardware components and software components, right? A computer consists of hardware components and software components. Now, input and output devices comes under hardware components because hardware components are nothing but the components of the computer that can be physically seen. Okay, so we'll be first discussing about the hardware components, and input devices are one of the hardware components. So input devices are hardware components that enable users to interact with the computer or electronic system by providing data or commands. So we have mentioned before that for a computer to process a data, we need to give a raw data into the computer first. So we use input devices to give raw data into the computer. The computer will process the raw data and give us the required output. So that's the whole procedure. And the input devices are the devices that help us in giving the raw data into the computer. It helps us to feed the computer. Okay. Now these devices allow users to input information and instructions for the computer to process. For example, keyboard, mouse, scanner, web camera, microphone, etc. Taking a simple example, if you want to search something in Google, or if you want to make a document in the Word file, what do is that we use the keyboard and we type in the Word document, right? The computer processes and displays as a document. So that's the whole procedure. And we use input devices to give the raw data into the computer. Okay, so now let's take a look at different input devices. One among input devices is keyboard. A keyboard is the most common input device used for typing text, entering commands, and controlling various functions on a computer. Need not explain it much further, right? Keyboard is used for typing text, entering commands, and controlling various functions on a computer. Now we have mouse. A mouse is a pointing device that allows users to interact with. Okay. So now mouse is a pointing device that allows users to interact with user interface by moving a cursor on the screen and selecting items. You know what a mouse is? We normally use a mouse to interact with the screen. To control what is happening on the screen, we use the pointing device, right? To click on something if you want to reach on to something. Okay. Now the next input device is touchpad. Touchpads are commonly found on laptops and okay, you know what is a touchpad is? Instead of a mouse, we use touchpads in laptop, which is having the same functioning as the mouse, to point out something on the screen by sliding our finger on the surface of the touchpad. Okay, next comes the touch screen. Touch screen is nothing but the screen of the computer, and we can directly touch the screen using our fingers and point to the icons that we need to access. Okay, this input method is common in smartphones, some desktop monitors, etc. Okay, and the next input device is webcam. A webcam captures video input and allows users to participate in video calls, record videos, or take pictures. You know what a webcam is? A webcam is also another input device. So these are some of the examples of input devices. You may please note it down. Keyboard, mouse, touchpad, touchscreen, and webcam. Okay. Now the next one is graphics tablet. A graphics tablet is also known as digitizing tablets or drawing tablets. These are used by artist designers to draw or write directly onto a digital surface using a stylus or pen. So graphical tablet is another example of an input device. It is nothing but these tablets are normally used by artists or designers to draw or write directly onto digital surface. For example, I can show you one thing. You might have already seen this one. This is a pen tab. Okay, this is a pen tab. This is an example for graphics tablet, and this is also an input device. Here, if you write on this, you can see on the screen. Okay. So this is an example of an input device. Now we have trackball. Trackball is another input device. A trackball is an alternative to a mouse. Please note, it is almost similar to mouse. If you search in Google, you can see the picture of a trackball. It looks almost similar to a mouse, but it'll be having a ball-like thing to rotate. Okay. Yes. So that's about the trackball. And next we have joystick. Joysticks are commonly used in gaming and controlling simulations. They consist of a stick which can be moved in various directions to control on-screen movement. So joysticks, you might be much more familiar with it because we use in gaming systems and all. Next, we have scanners. A scanner converts physical documents, images, or objects into digital images that can be viewed, edited, or stored on a computer. So scanners are another example of input devices. And next, we have microphone. A microphone captures audio input and allows users to record the voice, dictate text, or communicate with others through voice chat or video conferencing. So our mic is also another input device because it takes up the voice. Okay. So input devices are nothing but it includes all those devices that allows the users to interact with the computer or to give the raw data into the computer. So these are the different examples of input devices. Now we have some more examples. It includes the OMR, optical mark recognition. You might be familiar. Now for this time, UGC NET exam, we'll be having an OMR exam. We'll be having OMR sheet to record our answers. So those OMR is an input device. And the OMR sheet on which you'll be giving your answers will be inserted into a computer system, and the computer system will be automatically reading those answers. So that's the procedure about OMR system. And please note down the full form of OMR. It is nothing but optical mark recognition. These are the devices that are used to detect marks made by a pen or pencil or specially designed forms or documents. They are commonly used for tasks such as scoring multiple choice exams, surveys, or vote counting. So OMRs are normally used for multiple choice exams and or for surveys or vote counting purposes. Okay. Now, next input device is OCR, optical character recognition. OCR devices convert printed or handwritten text into machine readable text. Okay, please note it is very important. What does it do? It converts printed or handwritten notes into machine readable text. It is very important because normally OMR and OCR included questions are asked and you might get confused between the two. So please note that OMRs are nothing but they detect marks made by a pen or pencil on specially designed forms. For example, you can easily remember by using okay, yes. And OCR is nothing but it is OCR devices convert the printed or handwritten text into machine readable text. Okay. Now they are used to digitize documents such as scanned documents or images, making the text searchable and editable. So what do you mean by OCR? It is nothing but those that converts the printed or handwritten text into machine readable text. By using an optical character recognition, if you have a handwritten notes with you, you can use that and you can convert those handwritten text into machine readable text into digitized form. Okay, now the next input device is biometric scanners. Okay, you might have already heard about biometric scanners. What are biometric scanners? They capture and analyze biological or behavioral characteristics to verify a person's identity. Biometric scanners are used to verify a person's identity. Okay. Common biometric scanners include fingerprint scanners, iris scanners, facial recognition systems, and voice recognition systems. So biometric scanners are nothing but normally when we enter into an official space, etc., there'll be like punching systems. We use our fingerprints to mark our attendance. So that is a biometric scanner, and that is another input device. And also biometric scanners involves these fingerprint scanners and iris scanners. Now, what do you mean by iris scanners? Our biologically, our iris in the eye, it is said to have different pattern for different people. So by using the iris pattern in each person's eye, we can know the person's identity. So that kind of a recognition system is iris scanner recognition system. And biometric scanner includes facial recognition systems and voice recognition systems also. So in general, we can say that these are used to identify a person's identity. Okay. Then we have barcode readers. Barcode readers scan barcode symbols to retrieve information encoded in the barcode. They are commonly used in retail environments for inventory management, product tracking, and point of sale transactions. So barcode readers are commonly used in supermarkets. For example, we can say supermarkets for billing purpose because the product in the supermarket will be having a barcode behind it. And the barcode readers will scan the barcode, and thus the complete details of the product will be directly entered into the system. Okay, so barcode reader is an input system because it takes up the input of the barcode from the product. Okay, so that's all about the input devices. So as we have discussed, input devices are nothing but that allows or enables users to interact with the computer or any other electronic system by providing data or commands. So what do we do is that in order to give a raw data into a computer, an input devices can help us. It gives the raw data into the computer. The computer will then process the raw data and give us the output. Okay, so we have discussed different input devices. One among that is keyboard, mouse, touchpad, touchscreen, webcam, the graphics tablet, which might be a little bit new. A graphics tablet are nothing but these are commonly used by artists and designers to draw and write directly onto the digital surface. If you write on these tablets, it will reflect on the digital surface or the computer screen. Now for the trackball, it is almost similar to the mouse and it is an alternative to mouse. It functions same as a mouse. And we have joystick. Joysticks are used for gaming purposes. Then we have scanners. These convert the physical documents or images or any other objects into digital images. So what do scanners do? They convert the physical documents into digital images. Then comes microphone. It captures our audio and it digitalizes it. Okay. Next, we have OMR, optical mark recognition. These are commonly used in multiple choice exam systems, surveys, or vote counting purposes. Now, these optical mark recognition, we'll have a sheet for this OMR sheet, and we'll be marking the answers on it. When we feed this sheet into the system, it will automatically read the answers and digitalize it. Okay. Then we have optical character recognition. These are nothing but which converts the printed or handwritten text into machine readable text. Okay, then comes the biometric scanners. These captures the biological characteristics of a person to identify a person's identity. Okay, so there are different examples of biometric scanners. It can be fingerprint scanner, it can be iris scanners, it can be facial or voice recognition systems. Then comes the barcode readers. Barcode readers are normally used in supermarkets. The product will be having a barcode on it, which contains all the details of the product. And by using the barcode reader, we can scan the barcode and the complete details of the product will be entered into the system. Okay, hope it is clear. If you have any doubts, you can ask in the chat box. Is it clear? Now, from the exam point of view, if you take a look at the previous year questions, you can see that input and output devices questions are normally asked in a similar pattern. Like they'll be giving you a list of input devices or output devices, and they'll be asking you to identify those. So we have discussed many different input devices also. So please take a note of that and please don't get confused. Okay. Now, next we have output devices. So as we said, in input devices, what do we do is that we give the raw data into the computer. The computer processes the data and gives us the output. So the devices that help the computer in giving the user the output is called as output devices. Okay, we feed the computer through input devices. The computer gives us the product through output devices. Okay, so these are also hardware components that display, present, or output process data from a computer or electronic device to the user. So what do they do is that they display or present the output and the process data from a computer to the user. These devices present the results of the process data or actions initiated by the computer. The computer will be processing the data in a way like we want it, and it will be displaying it to us in the way we want it. Some of the examples of output devices are monitors, printers, speakers, headphones, projectors, etc. Okay, we'll be discussing in detail some of the examples of output devices. Okay, we have monitor as an output device, as you all know. Normally, an output is displayed through a monitor screen. A monitor is also known as a display screen or screen. It is a primary output device for computers and displays visual information such as text, graphics, and videos. Okay, so monitor is an output device. And next comes the printers. Printer produce hard copies of digital documents, images, or other content stored on a computer. Printers produce hard copies of digital documents, images, or the other content stored on a computer. There are various types of printers, including inkjet printers, laser printers, and dot-matrix printers, each with its own printing technologies and capabilities. So printers are another output devices. Why? Because they give us the hard copies of the digital documents. Suppose we create a Word document in the computer. We want to take out the printouts. We use the printer for the purpose, and the computer gives us the output through the printer. Next output device is the speaker. Speakers output audio or sound from a computer. Speakers output audio or sound from a computer or electronic device. They are used for tasks such as listening to music, watching videos, and participating in audio conferences, etc. Simple. Speakers are for allowing access to voice. Okay. Next comes headphones or headsets. These are another example of output devices. Headphones or headsets are audio output devices worn over the ears, providing a private listening experience for the user. So headphones, headsets, speakers, these are all output devices. The only difference between speakers and headphones are that these provide a private listening experience when compared to speakers. That's it. They are commonly used with computers, smartphones, and other audio devices also. And then comes the projector. The projector displays images or video onto a larger screen or surface, typically used for presentations, movie screenings, and large-scale displays in classrooms or auditoriums. A projector displays images or video onto a larger screen or surface. We know that if you want to see the product on a larger screen, we can use a projector and it displays the image or video on a larger screen. And next comes the plotter. Plotter is another example of the of the output device. Plotters are specialized output devices used to produce large-scale, high-quality prints of vector graphics, typically used in engineering, architecture, and design applications. So plotters are nothing but they are commonly used in engineering, architecture, or designer applications. And these are also another examples of output devices. Okay, so it is basically used to produce large-scale, high-quality prints. Okay, please note that it is normally used to produce large-scale and high-quality prints of vector graphics. Okay, then comes LED or LCD indicator lights. LED is nothing but light-emitting diode, and LCD is liquid crystal display. Please note down the expansions of each abbreviations. This indicates light provides visual feedback on the status of devices or systems, indicating functions such as power on or off, connectivity status, and battery level. So now, how can we say that LED or LCD indicator lights are output devices? Because normally in a system, like when LCDs or LED lights are connected to a system, for example, when the LED turns red color, it indicates off, and when it is green, it indicates it is on. So in that purpose, it can be an output device. Okay, next example is Braille display. A Braille display outputs tactile information in Braille format for visually impaired users. It converts digital text into Braille characters, allowing users to read text through touch. Now, Braille display is another example of output device because you know that it helps the visually impaired users, and this converts the digital text into Braille characters. Okay. So that's all about the output devices. I hope it is clear. If you have any doubts, you can ask. Okay, yes. Is it clear? Braille display is nothing but it converts the digital text into Braille character, allowing users to read text through touch. Okay, so what does it do is that when a digital text is given in a computer system, the Braille display will convert into Braille characters in a way the visually impaired users can touch and understand it. Okay. It can be simply connected to like we said when, for example, we can say printers. We use printers normally to take printouts of the digital documents. In a similar way, by using Braille display, the visually impaired users can use them. Okay. Okay, next we have CPU. Okay. So CPU is another hardware component of the computer. It is often considered the brain of the system. We might have already learned about this in lower grades. It is called as the brain of the computer. And now why is it called as the brain of the computer? It is because CPU is responsible for executing all the instructions and performing all calculations which are necessary for the operation of the computer system. Okay, so we can simply say that CPU is a very vital component of the computer that manages and executes all the functions and all the instructions related to the computer. Okay, the CPU interprets and carries out instructions from computer programs. Now we'll see CPU in detail. It basically consists of three units. One is arithmetic logic unit, the other one is memory unit, and we have control unit. Okay, the first one is arithmetic logic unit. Arithmetic logic unit is responsible for performing arithmetic and logic operations or data. So this unit does the addition, subtraction, multiplication, division, etc. The mathematical and the logical operations are dealt by the ALU system. And this ALU receives input data from the registers and produces output based on the operation performed. So what do they do is that, suppose when I give a raw data into the computer will read and start processing the data. So the CPU collects this raw data and it will, suppose if I'm giving some functions to perform calculations, the CPU will directly transfer this data into the arithmetic logic unit, and therein the calculations will be performed and we'll be getting the output. Okay, so that's all about the arithmetic logic unit. Then we have control unit. Control unit manages the flow of data and instructions within the CPU and coordinates the activities of other hardware components. So this is one of the major part of the CPU because it manages the flow of data and instructions within the CPU and coordinates the activities of other hardware components also. So we can say that it has two functions. One is manages the flow of data and instructions within the CPU. Okay, so control unit decides how the data should be transferred from one position to another. It controls the whole process of the flow of data and instructions within the CPU. And then also it coordinates the activities of other hardware components associated with the CPU. Okay, so the control unit does two functions. One is managing the complete flow of data within the CPU. The second is that it coordinates all the activities associated with the hardware components. Okay, so we can simply say that the control unit coordinates the operation of the CPU. Okay, it coordinates the complete operation of the CPU. It is the main part of the CPU. Control unit is a main part of the CPU. It fetches instructions from memory and decodes them, controls the flow of data between CPU components such as the ALU, registers, and memory, ensures that instructions are executed in the correct sequence. So as I said before, when I'm giving a raw data into the computer, this control unit fetches up the raw data first. Okay, and it will see whether it is a calculation. If it is a calculation, it will be transferring the data into the arithmetic logic unit. If it is something else, then to some other area. So the control unit is the one which receives the data in the CPU. It processes the data and see like from where it can be shared and where the processing can be done. And by understanding the method, it will be transferring to wherever possible. Okay. Now comes the last one, memory unit. The memory unit in a CPU provides high-speed data access to the processor and stores frequently used instructions or data. So what is the purpose of memory unit in CPU? The memory unit in CPU will store the data that is frequently used. Okay, not all data. It uses the data which is frequently used. Why? Because when a data is frequently used, that data will be accessed in future also many times. So whenever a similar program is asked to run by the CPU will directly fetch the instruction required to run this program from the memory unit, and then it will be processing the data. Okay. So that's all about the CPU. CPU is one of the major hardware component of the computer. It is often considered as the brain of the computer. It is the hardware component that is responsible for managing all instructions, performing calculations necessary for the operation of the complete computer system. It includes 3 units. The first one is arithmetic logic unit. The second one is control unit. And the third unit, memory unit. Okay, so the arithmetic logic unit performs arithmetic and logical operations or data. That is, if we are giving some input to the computer, asking the computer to do some calculation, then it will directly share the data to the arithmetic logic unit. Therein, they'll be performing the calculations and they'll give us the output through output devices. Okay, now control unit is the main part of the CPU. Whenever a raw data is given into the CPU, the control unit fetches it and it understands what kind of data it is. If it is some sort of calculation, it will share it to the arithmetic logic unit. And if it is some other functions, then it will be transferring to some other areas. Okay, then comes the memory unit. The memory unit in the CPU provides high-speed data access to the computer, to the processor, and stores frequently used instructions or data. Okay. I hope it is clear. If you have any doubts, you can ask. Shall I repeat any other portions? Okay, yes. I think we can wind up the session for today. We'll be discussing regarding software and its types and also computer network related in the next class. Okay, yes. Thank you, all of you. Thank you.